Every single day, more than 10 million aluminum cans are tossed aside around the world. Stack them together, and you'd have a towering mountain of scrap, enough metal to overwhelm a city the size of Los Angeles. But here's the remarkable part: aluminum never truly loses its value. Unlike many materials, it can be recycled again and again without sacrificing strength or quality. What looks like trash is actually the beginning of a new life inside advanced recycling facilities. Once collected, used cans enter a highly automated system. They're sorted with precision, shredded into small fragments, stripped of contaminants, and heated to extreme temperatures. After careful refining, that once discarded metal is transformed into brand new aluminum products. So what really happens behind the scenes? How does yesterday's soda can become tomorrow's airplane part? Globally, more than 70 million tons of aluminum are produced every year, a staggering number that highlights how essential this metal is to modern American life and beyond. It's in beverage cans, home construction, pickup trucks, commercial jets, even the devices we use every day. But with that scale comes a growing problem. As production rises, so does the volume of aluminum being thrown away. That's where recycling becomes more than just a good idea, it becomes a necessity. Today, roughly 35% of the world's aluminum supply comes from recycled sources. And the benefits are massive. Recycling aluminum uses only about 5% of the energy required to produce it from raw bauxite ore. That translates into dramatic energy savings, lower manufacturing costs, and significantly reduced carbon emissions. Incredibly, experts estimate that nearly 75% of all aluminum ever produced in human history is still in circulation today. That's the power of a true closed-loop material. The journey begins with what may seem like a simple step: scrap collection. Yet this stage determines the success of everything that follows. Here in the United States, one of the world's leaders in aluminum recycling, the system operates at an enormous scale. From grocery store can return stations to city recycling centers and large industrial scrap networks, aluminum flows in from every direction. Each year, tens of millions of tons are gathered from homes, businesses, and factories, feeding a continuous stream of material into the recycling chain, keeping the cycle alive and moving forward. What sets aluminum apart from other recyclables is simple: it holds real monetary value. Even the moment it's tossed into a collection bin, an empty aluminum can is worth several times more than a plastic bottle. That built-in value creates powerful financial incentive. Individuals return it. Businesses buy it. Manufacturers depend on it. That's one of the reasons the United States consistently ranks among the world's leaders in aluminum recovery. The country has built a system that not only captures massive volumes of used metal, but also feeds a steady, reliable stream of recycled material back into domestic manufacturing. This collection phase is more than just logistics, it's the true starting line of aluminum's second life. From delivery trucks overflowing with crushed beverage cans to sprawling scrap yards glinting under the sun, this is the moment aluminum begins its return to the marketplace, preparing to take on an entirely new identity. Across the country, collection centers serve as critical hubs in this operation. Convoys of trucks loaded with aluminum scrap roll into massive receiving yards day and night. Each truck is weighed, logged, and carefully tracked before hydraulic systems lift and tip the trailers, unloading their contents onto wide conveyor belts. From there, a constant stream of material moves inward. Soda cans from supermarkets, food trays from households, manufacturing offcuts from industrial plants, all of it converges in one place. Gradually, the site fills with towering piles of shimmering metal, rising like silver mounds across the yard. But speed doesn't replace precision. On-site technicians perform rapid inspections as loads arrive, checking for excessive contamination or hazardous materials. Any shipment that fails to meet standards is rejected immediately. The pace is relentless. Thousands of tons of aluminum pour in every single day, making the staging yard the front line of a massive, non-stop recycling engine that powers the next phase of transformation. That's why this plant serves as the true front line of the recycling pipeline, the decisive checkpoint where every incoming load is prepared for its next transformation: high-precision sorting. From here, steady rivers of aluminum scrap glide along long conveyor belts that operate around the clock. Mounted above them are advanced optical scanners, essentially high-speed electronic eyes, examining thousands of fragments every single second. Using differences in color, shine, and surface reflectivity, the system instantly recognizes what's aluminum and what's not. As the material continues forward, powerful magnets sweep across the stream, pulling out any ferrous metals like steel. Then, carefully calibrated blasts of compressed air fire in split-second bursts, pushing aluminum pieces away from plastic, paper, and other lightweight debris. Step by step, the separation technology refines the flow. What began as a tangled mixture of trash gradually turns into a cleaner, more uniform stream of metal. The sorted aluminum collects into organized, gleaming piles, bright silver against the industrial backdrop. At this point, the material is chemically consistent and tightly controlled, ready to advance deeper into the recycling process. Next comes size reduction. The purified scrap feeds directly into a massive industrial shredder. Conveyor belts drop crushed beverage cans, food trays, and factory offcuts into twin counter-rotating steel rollers lined with hardened cutting teeth. Under tremendous force, the aluminum is gripped, crushed, and torn apart almost instantly. The sharp clang of metal echoes through the facility as the machine pulls in hundreds of kilograms within minutes. This isn't random destruction, it's engineered precision. Rotating blades and heavy-duty impact hammers work in coordination with the rollers, breaking down even thick or rigid aluminum components with consistent accuracy. Under bright factory lights, a steady stream of silver fragments pours out from below, cascading onto the next conveyor like metallic confetti. A vibrating screening system then filters the pieces by size, ensuring every shard meets exact dimensional standards. By the end of this stage, the aluminum is no longer recognizable as cans or scrap, it has become uniform, precisely sized feedstock, perfectly prepared for melting and refinement. The shredded aluminum doesn't sit around for long. It moves directly into massive industrial furnaces, the heart of the entire recycling operation. Depending on the type of scrap and what the final product will be, the facility may use different furnace designs. Some rely on reverberatory furnaces for high-volume melting. Others use rotary kilns for mixed scrap. In certain cases, electric arc furnaces provide tightly controlled, high-efficiency heat. No matter the design, each unit operates as a sealed, carefully engineered system built to control three critical variables at once: temperature, airflow, and material movement. Inside the chamber, temperatures are maintained between roughly 660 and 750 degrees Celsius, hot enough to fully liquefy aluminum, yet carefully controlled to prevent the loss of important alloying elements. The shredded metal enters through overhead charging doors or tilting feed systems, then remains in constant motion. Mechanical stirrers or precisely injected air keep the molten bath evenly mixed, ensuring uniform composition. Many modern furnaces also integrate heat recovery systems to capture excess energy and improve overall efficiency. At the same time, advanced filtration units treat exhaust gases, trapping aluminum oxide particles and neutralizing potentially harmful emissions before they leave the stack. Throughout the smelting process, an array of thermal sensors and chemical analyzers monitor conditions in real time. These instruments act like the furnace's nervous system, continuously checking temperature stability and chemical composition to make sure every batch meets strict industrial standards. This is the most intense phase of recycling, where extreme heat, chemical reactions, pressure, and mechanical precision all intersect. There's no room for error. A single miscalculation could compromise an entire melt. But when everything runs perfectly, the result is a steady stream of glowing, purified molten aluminum, ready for the next transformation. And yet, even in its fully liquid state, the metal still contains microscopic impurities invisible to the human eye. Even in its molten state, aluminum isn't perfectly clean. Suspended within the glowing liquid are microscopic contaminants, aluminum oxides, fine furnace dust, leftover paint residue, and even traces of oil or grease from the metal's previous use. To eliminate these impurities, the refining process takes place right inside the furnace. The most common method is called fluxing. A carefully engineered chemical flux is added directly into the molten bath. As it reacts, it bonds with unwanted particles, separating them from the aluminum. These impurities gather together and rise to the surface, forming a lighter layer known as dross. That dross is then skimmed off, sometimes with automated equipment, sometimes manually by trained operators, revealing cleaner, higher purity molten metal beneath. In more advanced systems, inert gases such as argon or controlled amounts of chlorine are gently injected into the melt. As tiny bubbles move upward through the liquid aluminum, they trap dissolved hydrogen and excess oxygen, carrying them to the surface where they can be removed. Throughout this entire phase, temperature is carefully stabilized to maintain ideal refining conditions and achieve the exact chemical composition required for the next stage. Once laboratory checks confirm the aluminum has reached its target purity, the metal is ready to take on shape. The molten stream is transferred to the casting area, the point where liquid metal begins its transformation into solid form. This is a pivotal moment in the cycle. What was once a glowing, shapeless mass now becomes structured, measurable, and ready for handling. The aluminum is poured into specially designed molds made from steel, graphite, or other heat-resistant materials, depending on the intended end use. Some molds are vertical, producing traditional ingots. Others are horizontal, forming thick slabs. In high-volume facilities, continuous casting systems use water-cooled solidification to create a non-stop stream of metal with consistent dimensions. Every variable is precisely controlled: the speed of the pour, the temperature of the mold, and the intensity of cooling. If the flow is too fast, internal defects can form. If cooling happens too quickly or unevenly, structural weaknesses may develop. At this stage, precision isn't optional, it determines the integrity of everything that follows. If the molten aluminum pours too quickly, trapped gases can create air pockets or surface fractures. If the mold temperature is too low, the metal may solidify unevenly, leading to hidden structural flaws inside the block. At this stage, balance is everything. The process is like channeling water through a narrow passage; even a slight miscalculation can alter the final shape. Every setting must remain precisely calibrated to protect the integrity of the finished product. In many modern US facilities, casting is handled almost entirely by automated systems, guided by real-time sensors and computer controls. But in some semi-manual operations, seasoned technicians still oversee the pour themselves, making subtle adjustments in real time. It's a role that demands focus, experience, and split-second timing. As the aluminum cools and solidifies inside the mold, hydraulic systems engage. With controlled upward pressure, the newly formed metal block is gently pushed free from the mold walls. Heavy-duty mechanical clamps then grip the ingot, often weighing dozens of kilograms, lifting it out of the casting chamber and placing it onto a parallel steel conveyor. The sound of metal sliding against metal echoes across the foundry floor. Each ingot still radiates a faint reddish glow, heat shimmering off its surface as it begins to cool. One by one, the solid blocks emerge in precise rhythm with the machinery, lining up neatly along the moving belt. Immediately, automated sensors scan each piece, checking dimensions, surface quality, and structural accuracy to ensure no distortion occurred during release. From the casting line, rows of uniform aluminum ingots continue forward in perfect alignment, identical, measured, and ready for the next stage, marking the completion of one full cycle in aluminum's remarkable rebirth. Once removed from the molds, the solid aluminum ingots move into a preheating furnace. Here, they're carefully warmed and softened to reach the ideal temperature for shaping. This step ensures the metal has the right balance of strength and flexibility before entering the rolling line. When ready, each ingot is fed through massive counter-rotating steel rollers. The pressure is enormous. As the rollers grip the block, they compress and elongate it at the same time. The metal exits thinner and longer than before. This isn't a one-pass process. The aluminum travels through multiple rolling stands, each set of rollers positioned slightly closer together than the last. With every stage, the thickness decreases gradually and precisely. What began as a solid slab measuring 8 to 10 inches thick is steadily transformed into a smooth, flat sheet. Throughout the operation, a fine water mist cooling system sprays the surface. This controlled cooling prevents overheating, reduces stress in the metal, and protects against cracking or warping as the aluminum stretches thinner and thinner. By the final rolling stage, the sheet has reached its exact specification, sometimes just a few hundredths of an inch thick. It then moves forward as a continuous strip, gliding along the line before being tightly wound into massive coils. These standardized semi-finished coils are now ready for the next steps, whether that's cold rolling for additional thinning, precision cutting, stamping into can bodies, or shaping into other finished goods. And from there, the transformation comes full circle. Once processed into new cans, aluminum quietly re-enters everyday American life. It appears stacked on grocery store shelves, chilling in ice-filled coolers at backyard barbecues, cracked open at ball games, or shared around the dinner table. Every single day, hundreds of millions of aluminum cans are used worldwide, seamlessly woven into daily routines. From quick refreshment on a hot afternoon to celebrations with friends and family, these lightweight containers play a small but constant role in modern life. But here's the key: an aluminum can doesn't lose its value the moment it's emptied. That's when it faces a crucial choice: tossed into the trash as waste, or placed in the proper recycling bin, unlocking the potential for near-endless renewal. In countries with deposit return programs, more than 80% of cans make it back into the production cycle, often transformed into brand new products within just a few weeks. By contrast, cans that end up in general household trash become nothing more than environmental burden. Even though aluminum is one of the most sustainable materials ever made, the ultimate decision rests in the hands of the consumer. Every time you drop a can into a recycling bin, it's more than just a small action. It's a powerful contribution to a closed-loop cycle, a process that keeps aluminum in use, continually reborn, rather than buried in a landfill. We've just traced the incredible journey of aluminum's rebirth. From what first appears as useless scrap, it transforms repeatedly, back into soda cans, window frames, car parts, and even critical components in aircraft. This circular process isn't just a technological marvel, it's a reflection of the choices we make every day. And that choice comes down to one simple action: putting it in the right bin. So, what will you decide? Will the can story end prematurely, or will you give it a chance to continue its endless cycle, contributing to a greener future for everyone? If this video has changed the way you see aluminum recycling, hit that like button, share your thoughts in the comments, and subscribe so you won't miss our upcoming videos exploring the fascinating journeys of materials that shape our world.